Hello there, and welcome to another lesson in financial mathematics. Remember, in our previous lesson, we had started looking at how to calculate compound interest. And in that lesson, we looked at how to calculate compound interest using the adjusted simple interest formula. And we had already defined what compound interest is, where the unique thing about compound interest was that we not only calculate the interest accrued on the principal, but also on the interest that has been accrued on the previous periods. So in this lesson, we want to look at how to calculate compound interest using the compound interest formula. Calculation of compound interest using the compound interest formula. Remember also, when we were using the simple interest formula, we were able to get the amount at the end or at the closure of a given period, the bank balance. That bank balance, we call it the amount. And that amount included both the principal that was used to calculate the compound interest and the compound interest itself. So the amount, the total amount in an account, the total amount in an account the total amount in an account at the end of the period can be calculated by the formula this total amount, that total amount can be calculated by the formula amount is equal to the principal into bracket 1 plus the rate raised to the number of periods, n, the number of periods, n. Remember, we have also looked at how to calculate or to convert periods to get the number of periods, and also how the number of periods denoted by the letters, the small letter n, and also how to calculate the rates per period. That one we have already done. So just allow me to go through the different variables we have in this compound interest formula. A, we have agreed, stands for the total amount at the closure. We can say where A stands for the total amount at the end of the period. Total amount at the end of the period. While P is the principal amount. The principal amount on which the interest is paid or earned. We are talking of the interest being paid in the case of a loan or being earned in the case of an investment. Or we can basically call this as the amount that was borrowed, amount borrowed or invested. Amount borrowed or invested. While R is the rate. The rate of interest. This is the rate of interest expressed as a decimal. And that is the rate that is used to calculate the yearly interests accruing on our principal to help us to get the amount. And lastly, N is the number of periods. The number of periods over which a loan or an investment is made. These are the various variables that we have in the compound interest formula. So once we have calculated the amount, remember we are interested in the compound interest. The moment we calculate the amount, we will be able to get the interest. And this interest will be the difference between that amount minus the principal. This will give us the compound interest. So the moment we calculate the principal, the amount, we can be able to get the interest by just getting the difference between the two. Let us now move on and look at examples on how we can apply this compound interest formula, where we'll be using this formula to calculate the amount, or in some cases we can use the same formula to calculate the principal, or even use the same formula to calculate the rates or the periods. In question 1A, we are asked to determine the amount after 5 years if $4,000 is compounded annually at the rate of 8%. So you will discover that this question requires us to get the amount, and we already have the formula. Just like in the simple interest case, we proceed in the same version, where we start by listing down the terms together with their values that we have been provided with. That is the first thing. We list the terms together with their values. When you look at this question, the terms that we have been provided with, one of the terms is the principal, which is $4,000. We have also been provided with 5 as the periods, 5 years, and we have also been provided with the rate. These rates, the rate is at 8% per annum. 8% per annum, this will be the same as 8 out of 100, and we can express this as a decimal. To convert a percentage into a decimal, you basically divide that percentage by 100, and this will give us 0.08. So that is the rate that we are going to use. In other cases where we were dealing with fractions, percentages, even the simple interest case, I was advising you to use the rates in a fraction form. But when it comes to the compound interest case, it is prudent that you use the rates when they are expressed in decimal form. And here also we will require the help of our calculators, because we are dealing with decimal numbers. If we try to multiply decimal numbers manually or offhand, you can discover that it will take a lot of time. So I encourage you to have your calculator as we continue with this lesson. So having listed the items together with their values, the second thing we ought to do is to write down the compound interest formula. We write the compound interest formula, which we have said the total amount at the end of the period should be equal to the product of the principal, open the bracket, 1 plus the rate, close the bracket, raised to power n, where n denotes the number of periods. Having done this, the last thing we are supposed to do is to substitute the values and evaluate. Using a calculator. So we have the amount, we substitute in the value for the principal, which is 4,000. 1 plus the rates are 0.08, and the number of periods are 5. And this, we realize that it will give us 4,000 into bracket 1.08 raised to power 5. 1 plus this, it will give us 1.08. So this value here, 1.08 raised to power 5, is what will make us seek the help of a calculator. So you press 1.08 raised to power 5, you press the equal signs to get the answer, then that answer you multiply it with 4,000. When you do that, this amount will be equal to the amount will be $5,877.31. This is the amount that will be there. So The question was for us to determine this amount at the end of the period. We have done it. Let us look at the second part of this question, part B. The second part is for us to calculate the compound interest. The compound interest. And this is a simple question. We said that for us to calculate the interest will be the difference between the amount and the principal. Our amount that we have just calculated is $5,877.31 minus the principal was $4,000, and this will give us an interest of $1,877.31. This is the compound interest that will be accrued in a period of 5 years at the rate of 8% per annum. This will be our interest. Let us move on and look at another example, a second example, a third and fourth maybe, to help us internalize this compound interest concept, the application of the formula. The second example, the question is for us to determine the compound interest. Determine the compound interest given that $100,000 is compounded annually at the rate of 6% for 15 years. For 15 years. This is another question. This is another case, unique case that we are faced with. That we have a principal of $100,000 that is being compounded at the rate of 6% per year for 15 years. We are required to calculate the compound interest. In our just completed first example, we have said that for us to calculate that compound interest, this will be the difference between the amount minus the principal. We already have the principal here. Do we have the amount? No, we don't have. So we need to calculate this amount first before we get the the compound interest. And for us to calculate the amount, we need to use the compound interest formula. And before we use the compound interest formula, we have agreed that it is prudent for us to list down those items that we have been provided with. Like the principal we are given is $100,000. The rate we have been given is 6%, and this written as a decimal number, this will be 0.06. You divide it by 100. What else have we been provided with? We have been provided with the periods N, which is 15 years. Having listed down all those terms together with their values, we come and write down the compound interest formula. Amount should be equal to the principal into bracket 1 plus the rate raised to power n. After we have written down this formula, we go ahead and substitute in the values. Amount will be equal to the principal, the rates, and then 15. And this will give us $100,000 multiplied by 1.06 raised to power 15. And if you carried out this using your calculator, you will get the amount as 239,655.82. This will be the total amount at the end of the period, and our period is 15 years. At the end of the 15th year, we will have this amount in the account. So from here, once we have the amount, we can go back and calculate the compound interest from this first formula of the relationship between the amount and the principal. Now, our interest will be equal to the amount we have it, 239,655.82. Do we have the principal? Yes, the principal we were provided with. The principal is $100,000, and this will give us $139,655.82. This is a very big interest to be accrued when you look at it. In fact, it is more than the principal amount that was invested. The reason is because the number of periods. It took 15 years for it takes 15 years for one to accrue such a colossal compound interest. This is what the question required us to do. Let us move on and look at another example. I hope you have understood this one. Let us look at a third example, a fourth one, and maybe we can look at something else. So when you look at these examples, you will discover that using the compound interest formula is easier, and it is more direct, unlike using this adjusted simple interest formula. You move from the first year to the second year to the third year, and like the example that we have just done, the period was 15 years. You can imagine you are starting to calculate the compound interest from the first year, the second year, the third year, down to the 15th year. That will be a very tiresome task to do. But with the compound interest formula, it makes things easier and simple for us to handle such questions. Because one can give you even a period of 20 years, 30 years, you cannot use the simple interest formula. So that is one of the disadvantages of the simple interest formula. It is only limited to a smaller number of periods, maybe from the first to the fifth. Even the fifth year is something tiresome. But with the compound interest, we can even calculate to the million and millions of periods. Let us look at the third example. A certain amount was compounded annually at 5% for 5 years. For 5 years. The amount accumulated in the account at the end of the 5th year was 5,105.13 $0.13. The first question is determine the principal amount. Determine the principal amount. We determine the principal amount. We have a certain amount that we don't know. That amount can be X, can be any other letter. This amount was compounded annually for at the rate of 5% for 5 years. And at the end of the 5th year, the bank balance read $5,105.13. So we want to know the principal amount that was invested for this amount to be realized at the end of the 5th year. We are going to list down the terms that we are provided with. The first one is the amount we have been given is 5,105.13. Have we been provided with the principal? No, we have not. Have we been provided with the rates? The rates are 5%, which is the same as 0.05 expressed as a decimal. Have we been provided with the period? Yes. These are 5 years, 5 periods. So after listing the items, and as usual, we go ahead and write down the compound interest formula. After writing down the compound interest formula, we substitute in the values. Should be equal to the principal, which we don't know, into the brackets 1 plus 0.05, close the brackets, and we've been provided the periods as 5. So when we try to simplify the right hand side of this equation, we will have 5,105.13 being equated to the principal multiplied by this plus this will give us 1.05 raised to power 5. So the principal, for us to remain with the principal alone, we divide all through by 1.05 raised to power 5. And this will cancel, so that our principal will be equal to when you take this number and you divide by 1.05 raised to power 5, we are going to get a principal of $4,000. So this amount is what was invested. This is what was invested at the beginning, and it is the amount on which a compound interest accrued giving us an amount to the tune of 5,105.13. The second part of this question, calculate the interest accrued. Calculate the interest accrued. We agreed that the interest is equal to the difference between the amount and the principal, and the amount we were given as 5,105.13, while the principal we have just calculated is 4,000, and this will give us 1,105.13. This will give us $1,105.13. This is the interest, compound interest that has been accrued over a period of 5 years, given a principal of 4,000 at the rate of 5% for 5 years. That was the third example. Let us look at a fourth example, example number 4. Calculate the compound interest given that $6,500 is compounded annually. Is compounded annually at the rate of 16% in 6 years. In 6 years. This is like having two questions in one, because we know at the end of it all, we must be able to calculate the compound interest. And there is no shortcut, there is no a shorter route for us to arriving at the compound interest, not unless we have calculated the amount. If we are provided with the amount together with the principal, we can just find the difference. But since we have not been given, we first of all calculate the amount before we calculate the interest that the question so requires. And for us to calculate the amount, it is a routine that we need to list down all the terms that we know together with their values. So the first term, the principal we've been given is $6,500. We have also been provided with the rates, which is 16%, and this, if it is divided by 100, you will get 0.16. Lastly, we've been provided with the period, which is 6 years. After listing down the terms together with their values, we go ahead and write down the compound interest formula. After writing the compound interest formula, we substitute in the values. After substituting in the values, we simplify, we evaluate the same. At this particular point, we cannot calculate manually. This means we have 1.16 times 1.16, 6 times. That is why we need to use a calculator. And if we do that, this will give us an amount to the tune of 15,836.58. This is rounded off to the nearest dollar, So we are saying that if you invest $6,500 at the rate of 16% compounded annually within 6 years, at the end of the 6th year, you will have an amount totaling to 15,836.56. But the question required us to calculate the compound interest. And our compound interest is the difference between that amount minus the principal that was invested. Or if it was a loan, that interest accrued will be the difference between the amount accrued and the principal amount that was borrowed. This will be 15,836.58 minus $6,500. And this will give us 9,336.58. This will give us a compound interest of $9,336.58. When you compare even the interest and the principal amount, you'll discover that the interest has exceeded the principal amount that was invested. But this requires someone to have patience, because you cannot just earn this amount if the rates are this within a short period of time. You need a sizable amount of period, that is to the tune of 6 years before you earn this. So those are the 4 examples that I wanted us to use to familiarize ourselves with the compound interest formula. There is another unique situation whereby you can buy something like a vehicle, you use it after some time, and when you decide to sell it, you discover that it cannot fetch the same amount that you used to purchase the same vehicle or any item. There are those cases. You buy a computer, you use it for some time, and then when you want to sell it, it is taken to be second hand. It fetches an amount lower than the buying price that you used to buy the same item. What am I driving at? This is a unique case of compound interest. In fact, we usually refer to it as the reverse compound interest. Instead of the value appreciating, the value is depreciating. The value is reducing. So I want us now to use this time to look at what we call depreciation. So compound interest, when the value is appreciating the way we have just looked at it, it is what we call appreciation. And some items that do appreciate in value as time goes by, an example of that item is land. The value of land never depreciates, but rather it appreciates over a number of years. So let us look at depreciation, because it is some kind of the reverse of what we are talking about. It is still under compound interest. It is called depreciation. Depreciation, we are saying this is the reverse. The reverse situation of compound interest, of compound. Compound interest. where the value of an item keeps on reducing period, which can also be termed as year after period, period after period, or year after year. The value keeps on reducing by a certain percentage. By a certain percentage. So the value of things keep on reducing. After the first year, the value has reduced by this percentage. After the second year, the same value has gone down by the same percentage. So we need to look at this situation. And to look at that, let us look at an example. And in this example, we might have two ways in which we can solve it. After 2 years, calculate the value of a computer after 2 years if it was bought at $1,000 and depreciated at 30% per year. If it depreciated at 30% per year. So the buying price of the computer is $1,000. And I've said in this, we can have two methods of handling this case. The first one is where we calculate the depreciation year after year, so that at the end of the second year, we look at how much is the value of the same item. So we can have two methods, and let us look at method 1 first. Method 1. In this method, we subtract the depreciated value, the depreciation value or the depreciated value every year. Simply that. It is as simple as that. Whereby we have the first year or year 1. Year 1, the computer's value was at $1,000, but then we subtract the depreciated value, which is 30% of this, 30% of the buying price, 30% of the $1,000. We subtract that. What do we get? You first of all calculate 30% of 1,000. You calculate 30% of 1,000, and 30% of 1,000 is roughly, it is exactly 300. So 1,000 minus 300, it will give us 700. What does this particular value mean? This value shows that at the end of the first year, the value of the computer has depreciated from $1,000 to $700. Then we move on to the second year. Year 2. In the second year, we also do the same. We have Now the value in the second year, we are starting at $700 minus the depreciated value, which is 30% of the 700. 30% of the 700, because every year it depreciates at a rate of 30% of the value in that year. And this will give us $490. So this is the value of the computer. At the end of the second year, this is the value of the computer. The computer will be valued at $490. And remember, the initial value of the computer was $1,000, but it has depreciated to this level where it is only worth $490. This is the value of the computer at the end of the second year. That is the value. This was the first method, and we said that we have two methods of handling this case. The first one is the manual one. We could call it the manual, or the second one where we apply the adjusted compound interest formula. So allow me to go through the second method. Remember, the first method has its disadvantages. It is advantageous when we are talking over a small number of periods, maybe 1 or 2 periods. But when we lengthen the number of periods, then you discover that it is tedious. That is when we require to have another method, that is method 2, where we apply the compound interest formula. And in this compound interest formula, you will discover that in the bracket, everything else remains the same, but in here, we have a negative instead of addition. If you have addition, it means that the value is appreciating, and that is called appreciation. But since we are talking about depreciation, we introduce a negative here. That is why I said we adjust the compound interest formula to help us handle the situation in depreciation. So instead of having the addition, we have the subtraction. That is what we are going to use here. With this formula, we list down the terms together with their values that we have been provided with. The principal is the initial value of the computer before depreciation, and the rate, we are given a rate of 30% per year. And if you express this as a decimal, you divide by 100, this will be 1.3. The number of periods, we have 2 periods, so that is 2 years. The number of periods, we have 2 years. So with these terms together with their values, we go ahead and substitute in. The principal is 1,000. 1 minus the rate, which is 3. The rate of depreciation, we call it the rate of depreciation raised to power 2. And this will give us 1,000. 1 minus 0.3, this will give us 0.7 raised to power 2. And this will give us $490. You discover that the compound interest formula is always the best when calculating both appreciation and depreciation. It is easy for us to achieve that end result. So having looked at the compound interest formula, the different terms we have in the compound interest formula, and how it can be applied to solve questions pertaining to compound interest together with depreciation, I hope that you have understood that concept. And before we end this lesson, I want now to take this opportunity to give you an assignment that will help you during your revision. Determine the amount and the interest if $6,500 is compounded annually. Annually at the rate of 8%. That is our first question, that you determine both the amount and the compound interest if $6,500 is compounded annually at the rate of 8% for 5 years. Over 5 years. Over 5 years. The second question is for us to calculate the amount, after 4 years, given that $8,000 is compounded annually at the rate of 8.4%, 8.36, at the rate of 8.36%. That is the second question. And the last question touches on depreciation, the last concept that we have just learned. A car worth $20,000 loses 15% in value every year. Loses 15% in value every year. How much will it be worth at the end of 4 years? How much will it be worth at the end the 4th year? So the two first questions touches on compound interest, just that, but the last one touches on depreciation. I hope you have understood the two concepts, the compound interest formula, its application, and how to calculate depreciation. I hope you have enjoyed the lesson. Welcome in my next lesson, and thank you.